Okay. Hi, everyone. Welcome here. I'm very happy to introduce this contest today. I'm Maria Chiara Fortuna, and I'm the chair of IRAM 2020, the conference which is the container of today's event. Maybe some of you already know what is IRAM. Maybe some others even know what is Milan Noir, the association behind these events. And maybe some others are here just because of CovidR, the contest that we are going to watch. So I'm here to tell you the story behind these events, to tell you how this event will work, and also to introduce you OPIN, the platform where we are hosted today, so that you can enjoy this event fully. And so, okay, as you will see, the things are really interconnected. Okay. So, if last year someone had asked me what will happen on May 29, 2020 at 3 o'clock, I would have answered, we are in the University of Milano Bicocca, and it's the last day of IRAM 2020, so we are ready to have the last keynote. And the conference is almost over. We have already had keynotes and invited speakers and more than 100 contributors. We have already had the hackathon, the poster session, the Shiny demo session, and we are ready for the last day, the workshop day. But today is May 29, and it's 3 o'clock, and things are not going this way. So what happened? I think you all know the answer. Coronavirus jumped in our lives and changed everything. And it gave the idea of today's contest, but not only this. So let me step back a little bit again. So last year, the city of Milano won the hosting of IRAM 2020. What is IRAM? IRAM is the European R Users Meeting, the annual conference where our users and contributors from all around Europe get together and share contents and news about R. So it's a multi-day conference with parallel session with workshop and satellites events. I'm one of the main organizers of Milan Noir, so I started this adventure, but luckily a glorious team joined me, the people that you may see around also today, that are the heart of this conference, the IRAM organizing committee. So we worked for months to create an event as the one that I described before, a multi-day conference in Milan. And we have already finalized the program with more than 100 contributors and opened the registration when the epidemic reached Italy and then the world. So at the beginning, we considered today's scenario very remote. But we started to wonder about the feasibility of this conference. So in the first 2 weeks of March, we had really tons of call, and we drafted scenario over scenario, and we asked if we could maintain the conference or postpone to August or postpone to November. But meanwhile, the pandemic started to reach Spain, France, Germany, US, and then the rest of the world. So on March 31st, in a very difficult meeting, we decided to embrace the revolution. So we turned the conference into a fully virtual event, which is the first multi-days fully virtual R conference. So we decided to move the event to June 17 to 20 to have enough time to reorganize everything. And we had to throw away a lot of things like the venue, the catering, the social event, the travel grants. And yesterday we published a post remembering all these things. But we also decided that we wanted this virtual conference to be as similar as possible to a physical meeting. So we started to look for a technical tool that could allow a virtual full experience. And so we found OPIN, the platform that we are using today. So now I'm going to tell you how this platform works, and so what you can expect today, that you can fully enjoy the event. So the place where I'm now is called the stage, and the stage is the equivalent of a plenary area in a physical conference. Today in the stage, you will see the CovidR presentation. So it's the area for the talks, for the awarding ceremony. But during Iran, the stage, we lost our main guests, the conference keynote and invited speakers. So the conference is organized in 6 tracks, as you can see here. For the tracks Data Bits and Shiny, we will have Sharon Maklis. For the R application, Jared Lander. For the R word, Thomas Calibera. For our introduction, Kelly O'Brien. For machine learning and models, Francesco Bertolucci. And for our life science, Stephanie Hicks. We also have some very other well-known R names. So our invited speakers, Ioannis Cosmidis, Colin Gillespie, Melly Salmon, Colin Fay, Robin Loveless, Edwin Toens, Lisa Pavka, Britta Velten, Romain Francois, and Dina Tali. So if you want to know better our keynote and invited speakers, you can check our Iran profiles on YouTube, where you can see some interviews. Our conference was organized also in parallel session. And on the bar on the left side, you can see the other area of the virtual event, including the session. The session area hosts parallel rooms. So in this area, we will have the parallel session during IRAM 2020. And this area will host the contributed talks, the poster session, the Shiny demo session. And it will also have the Q&A areas, some area for the recruiting session, and some open lounges. Because this session area works also like the equivalent of the bar of the garden in a physical conference. So today we will have 3 rooms where you attendees, you participants can interact with speakers and organizers, and an open lounge for random chatting. Going down to the networking bar, you can see the networking, to the bar, you can see the networking button. This is the equivalent of drinking your coffee at a coffee break, and a random person just join you and start to talk. If you go there, you are matched with another random attendee from the networking area, and you can start a face-to-face conversation. But if you don't like the conversation and the person is boring, don't worry, because after 4 minutes, the person change, like in a speed date. The last area is the expo area, where you can find and meet the conference sponsor. It's thanks to them that this conference is free and open to everybody, so we really want to thank all of them for their support. Today, there you will find one of our main organizing partners, Mirai Solution, so feel free to go there and meet all of them. If you get lost in the reception, you can find some instruction and the event schedule and all the relevant links. We have also opened a Slack workspace, and you can find the link pinned on the event chat. There we will collect the question for the Q&A sessions, and you will also find some tech support if you have troubles. Just to conclude, we were able to maintain also the workshops and the hackathon that we have planned in the regional conference. So the workshop will be on June 20, 5 in the morning and 5 in the afternoon, and their topics will range from GitHub and Shiny to machine learning and web semantics. So I'm sure there's something that you will like there. And the hackathon about spatial networks is on June 16. So now you know the full calendar of the event. If you're not registered, feel free to go to the registration page. With the participation to the conference is totally free. You can leave a free donation, but it's just your choice. Just an extra word about CovidR. The idea of CovidR was the same days where we were working on virtualizing Iran. So the idea of this contest belongs to Francesca Vitalini, which is the Iran vice chair, and she is not today. Today is not here because she has just had her baby, so a big hug for her. And I also really want to thank all the organizing team for the great work. So, okay. Okay, I think this is all. So I leave the word to Riccardo Porreca, that will introduce the main part of the event and my best wishes for the speakers. I'm very curious to see your contribution. Bye, Riccardo.
Thank you, Maria Chiara, and welcome everyone from my side. So just a few words about the event we are all attending today, very, very quickly. So this is an event that was aimed at collecting open source our contributions around the topic of the COVID-19 pandemic. It's an initiative that us as the IRAM committee wanted to have to keep, actually despite the pandemic, to keep the community active around IRAM and around basically the importance of like studying with R or using R to study the COVID-19 pandemic. The contest was open source, not just because the contributions had to be open source, but actually all the machinery behind the contest is in fact based on an open source GitHub repositories where contributions have been submitted via pull request or issues. And this was another way to engage the community in the contest. And as part of it, basically all the contributions, and as you have probably seen, have been collected in a gallery website. And in total, we had 35 contributions, actually from all over the world. I think we only miss Antarctica as a continent, which was very nice. We had very early contributions, which helped getting some momentum. And we get quite a lot of last-minute contributions, also giving the feeling like people and contributors maybe had some ideas before, but with the contest in mind, basically brought the project a bit farther and made it to be presentable at such a contest. We also involved the community in the contest by allowing people to vote, again, using some open source tools based on GitHub. And we had more than, I think by now, more than 300 unique voters, which is a good contribution from the community. And today you are going to see the 15 that we selected for presentation today. And of course, we are very, very thankful for everyone who contributed and submitted their work. I think it gave a very nice overview of what people have done and can do in R with R in this contest. Just another big thank is to the people within the IRAM organization that worked more closely with Francesca and myself to make this happen. So Francesca has been already mentioned, and she was basically the mind behind the whole thing. Andrea and Emanuela, Daniel and Nicola, thank you all, and on behalf of all of us, thank you to all the contributors and all the attendees today. There are actually another two members of the team that I would like to mention. One is the Octocat, so we use GitHub Actions a lot to automate most of our processes. And unfortunately, we also had to deal with the angry GitHub unicorn, which was very present, unfortunately, during the last few hours of the submission. So with this, let's kick off with the presentations. This is a quick schedule. There will be an awarding ceremony at the end, around 5:45. And actually, thanks to also our sponsor, our platinum sponsor, our studio, and two of our keynote speakers, we will be in a position to give a few awards. So there will be the chance for a handful of contributors to get awarded. So with this, I think I will just wish all the best to the contributors who will present their work today, and I wish you a great event. Come to chair.
Thank you, Riccardo, and thank you, Maria Chiara, for introducing this event. So I will be chairing the three sessions. Well, chairing, making sure that we keep up with the scheduling. We have a very tight schedule, so hopefully we will be able to keep up with it. So it's time to start with the first session, and our first speaker is Mark Hanley. He's statistician at the Center for Big Data Research in Health at the University of New South Wales in Sydney, Australia. So please, Mark, share your camera and your presentation. Okay. Okay, here is Mark.
Hello,
welcome.
Everybody. Thanks, Samela, for that introduction. Sorry if there was a slight lag there. So I'll just say thank you. Oh, no worries.
I'll leave the floor to you.
Great.
Okay.
Yes, thank you to the organizing committee. It's really a privilege to be able to present our work today. Hello to everyone in Milan, Europe, and around the world. I'm just going to share my slides, so give me one moment. And I'll also turn off my speaker video just so you can focus on the slides. Okay. So I'm going to present the CovidR package, which I'm presenting on behalf of our team that also includes my colleagues Oisin Fitzgerald and Tim Churches. COVID stands for COVID-19 Open Source Infection Dynamics. And the COVID package provides users with a set of tools for modeling COVID-19 while incorporating time-varying interventions. So users can choose from 7 different epidemic models, but they can also apply flexible time-varying interventions. They can calibrate their models to existing data, and then they can also project over time under various projection scenarios. The package also includes a Shiny interface to help users quickly orientate themselves to the workflow. So I'm going to spend a few minutes describing these various features of the package, but first I'll briefly mention our motivation. So obviously how governments respond to this pandemic has profound health and economic consequences. And because these decisions are so important, it's imperative that the underlying models and the assumptions are explicit, transparent, and open for debate. Highly influential modelling from the Imperial College London has informed policy in the UK and internationally. However, this work has been criticised for having opaque code and results that can't be replicated. Here in Australia, the pandemic response was informed by a similar compartmental model. Details of this model were published in early April, but the underlying analysis code was not released. So our project started out as an effort to implement similar models, but in a way that would be open source and reproducible. With these goals in mind, the OR language was the natural platform for our work, and an open source OR package was the ideal way to disseminate. So now a bit about the features of the package. The COVID package allows users to choose from 7 different variations of the standard SI-OR epidemic model. The simplest model includes 3 compartments: susceptible, infectious, and recovered, and more nuanced models incorporate additional compartments. Because age is a key determinant of disease transmission and prognosis, the models can also account for population age distribution, as well as the estimated social contacts between age groups at country level. And we have built-in functions that will allow the user to choose demographics from over 150 countries that are shipped with the package. So here's a quick comparison between Italy and Ireland, and you can see the older age distribution in Italy, for example, and you can imagine how these things are very relevant. Now, during the early stages of the pandemic, these types of models were used to support policies to, hashtag flatten the curve. But once the curve is flattened, the question becomes, how soon can we re-emerge and under what conditions? So to help address these questions, the models implemented in the COVID package allow the user to specify flexible time-varying interventions. And this is an example of one of those. Interventions can target 2 facets of infection dynamics that can be influenced by policy. The first is the number of daily contacts, and that emulates things like social distancing. The second is probability of transmission, and that emulates things like mask wearing, washing your hands, and so on. It's also possible to explore interventions that target specific settings. So for example, you could have different time-varying interventions for school and workplace, if you're particularly interested in school closures, for example. Now, with the ability to specify flexible interventions, users can do 2 things. First, they can use the history of policy interventions in their country since February to calibrate their model to existing incidence data. Once you've calibrated the model, you can then start to project and see what happens next over the coming months. and you can start to compare different scenarios. So all of this functionality is available in the downloadable package, but there's also a Shiny interface available that you can launch from within the package, or alternatively, you can access online. The COVID package is a work in progress. Our future plans include adding contact tracing to the models and incorporating arrivals and departures, particularly to reflect the opening of land and sea and air borders.
Mark, I'm sorry to interrupt, but I'm afraid you're running out of time.
No problem.
So if you can quickly go to the very end of the presentation and... or if it was over.
Yeah, I think I pretty much got to the end. I guess I'll just wrap up to say that, in summary, the COVID package is an open source or package that allows you to model disease transmission and to implement time-varying interventions, both past interventions that have already happened and then future interventions that you're interested in exploring. And it's all done in a way that's open source and reproducible. So I'm a member of a team of 3, and Tim, Oisin, and I will all be around at the break to answer any questions you have. So thank you very much.
Okay, thank you for your presentation. I don't see any questions from the audience, but we do have a separate session during the break, so all of you speakers will go there and we'll take questions from the audience. And yeah, thank you very much, Mark. We move on to the second speaker, who is Nicola Farina. He's Director of Innovation at CovidR Formazione. Okay, welcome, Nicola. The floor is yours.
Hi, everybody. Thank you. I want to thank you, the organizer, for inviting me. I'm Nicola Farina. I'm the director of CovidR Formazione. CovidR Formazione is a small company based in Rome, Italy, which offers data-driven solutions based on data science, machine learning, and artificial intelligence. So in this very few minutes, I don't have a full presentation, but I would like just to show some of the features of our applications. This is an application that started for fun. I will say some of our colleagues looked at the data and they saw that, look, we have to represent in some way this data and see what these data actually are telling us. We're talking about the spreading of coronavirus in Italy, of course. Okay, we have several different tabs. I want just to show some of the graphs and the features of the application. There are some, the first tab is about forecasts. Of course, we are not epidemiologists. We are not going to model in a realistic way the spreading. We will just notice that there are a few models that actually represent and reproduce well the data. In particular, the Gompertz model, which actually seems to fit the data, as you can see in this plot. And we choose this model also because it is a useful tool to monitor the spreading and to tell us whether the things are going bad or not. In particular, if we see this table, which is interesting in my opinion, the Gompertz model tells you how far are you in the spreading of the coronavirus, okay? And so if this spreading actually increases over time, it means that you are actually on the right path. And so we will see for each days how much ratio of the expected cases and observed deaths we already seen are on the total that we will have eventually if the things continues to behave like that. Of course, whether unfortunately things won't go that well, we will see that the data won't follow this Gompertz behavior, and we will have a nice representation, and we will realize this. Another features that I'd like to present is the intensive care tab, which is, I think, what is a very impressive view of the spreading of the coronavirus. In this plot, we just plotted over time the number of intensive care beds occupied by COVID patients compared with the total number of intensive care beds. And you see in this animation how fast the things went at the beginning of the epidemic, the spreading. And you see that in just a few weeks, in some regions, you have a lot of COVID cases. But luckily for us, we were able to change route of this epidemic, and now, starting from mid-April, you see also that you have a reduction of the intensive care beds. But the speed on which that happens, it is very telling, and this is basically was a tragedy for our national health system. Another view that I want to share about this application is a regional one. We offer different statistics on the spreading at a regional level. And for instance, we see in this plot how many new cases you have compared to the actual cases. At the beginning of the epidemic, of course, you expect, sorry, but I had a guest in this moment. And at the beginning of the epidemic, you see that the number of new cases in the x-axis is actually proportional to the number of actual cases. As long as the epidemic goes on, you see a reduction of these cases, and this is a strong indication that things are going much better in the last few days, in the last weeks, and so we hope to follow this behavior in the future. Okay, that's it. There are a lot of other stuff in this application. I hope that you have fun visiting it. The final, of course, tab is about us, Pangea Formazione. I invite everybody to write us to have more information about it, and so we happily reply to each request and just to know our reality. Thank you.
Okay, thank you very much, Nicola. You were perfectly in time. I don't see any questions again. We have a dedicated Slack channel where that is pinned at the top of the chat, where we take questions from the audience. But again, the best way to actually get questions is to go to the dedicated speakers lounge during the break. Thank you, Nicola. That was very, very interesting.
Thanks.
And we'll
bye all. Thank you.
Speaker. Bye. Thank you. We'll move on to the third speaker, who is Ben Phillips. He's Associate Professor at the University of Melbourne. So we do have a second Australian presenting today. Ben? Okay, here is. Okay, welcome, Ben.
Hello.
The floor is yours.
Thank you. Thank you. So, 1 second. I just need to pick which screen I'm showing. There we go. So in late January, I'm just going to turn myself off. In late January, I started watching every day the Johns Hopkins University. And it didn't look like this. It looked like there was a lot fewer dots on the map. But with this dashboard, I watched coronavirus leave China. And in early February, I pipelined their data to my desktop, and I started looking at the trajectories of individual countries, and there were concerning patterns. In late February, I realized that we could see the future. And when the situation in Italy hit the international news, I was not surprised. I was horrified, as were we all, but I was not surprised. But the public conversation was not where it needed to be. It was weeks behind where it needed to be. This thing was outflanking us, and I was really worried about the fact that not everyone was as worried as I was. Eventually, I realized that it was because the media was failing to tell the story that needed telling. the media was caught telling the shocking story of the day, which was, today we saw more coronavirus cases than we saw yesterday. I realized that there were two things that were not happening in the public conversation, that were not being communicated very well. And I thought the first of them was exponential growth, the fact that populations grow surprisingly fast. And I think we are not cognitively well set up to understand exponential growth, and it has an amazing capacity to surprise us. And the second was detection, the fact that the cases that are reported are only a small subset of the true number of cases. And of course, it's the true number of cases that drives the impact of any epidemic. So in early March, these ideas crystallized in my head, and I put together a Shiny app that updated daily. I'm not sure why my PowerPoint slides are not updating daily. That updated daily and gives a 10-day forecast using a simple exponential model. But it also estimates detection, and provided that for every country in the Johns Hopkins University database. In the first 2 weeks, and so I put this out as a tweet and said, here's this thing, it'd be great if people could help. And in the first 2 weeks, I was a bit overwhelmed by the response. 11,000 people from 110 countries read the methods blog. 1,800 people went and visited the GitHub site. 30,000 people approximately used the site in the first 2 weeks. Probably the most exciting thing for me out of that was a small but wonderful community sprung up around the website. People who just wanted to help and who had an impressive set of skills to contribute. Between us, we have, there's been many since then, but the core business of projections for 10 days and detection. We now have a couple of forecast models, undiagnosed as well as infections, aggregates. Home and we're all in lockdown time is often to come by. The website is still being used. We put Google Analytics in around about the 1st of April, and it's had about 43,000 users. It's helped many businesses make decisions. It's forewarned many people about what was on its way. And it's helped people monitor what was going on in places they cared about, places where their loved ones are.
Okay, I think probably we lost the connection. Manuela, are you there? Okay.
Yeah, I think Ben just lost connection. Okay. Shall we maybe wait a few seconds, see if he comes back, and then we just move on to the next speaker and then come back to him when he's back. Yeah, it may take him a while to be able to come back, but yeah, connecting from very far away, it's really hard to keep track of all these. Okay, yeah, so we actually did get a few questions from the first two speakers, but there is a bit of delay, so I get questions, so they see the end of the presentation like a few seconds after it finishes, so I do not have enough time to I mean, there is a bit of delay, so we do not see them coming quick enough. And yes, I'm sorry for those who did ask questions, but we will keep in mind those questions, and then we'll ask them during the dedicated sessions. Yeah, so we won't forget them. Keep asking questions and keep voting questions. You can put like thumbs up if you like the questions, so that we make sure that those are relevant to many people, and we make sure that they are tackled during the dedicated sessions. Okay. I guess we can move on to the next speaker and then come back to Ben when his connection is more stable. So the fourth speaker of this session is Wei Sun. He's front-end engineer at Yahoo in Japan. Yeah, please, Wei, share your screen. Okay, here you are. Welcome, and the floor is yours.
Hi, everyone. And hi, everyone. Here I will going to introduce my project, COVID-19 Bulletin Board. Before I start to walk through the project, I need to explain a little about the positioning of the project. The following points are the ones I value the most. First, ability to reflect real-time numbers as soon as possible. Second, presenting data in as many dimensions as possible. Third, focus on dynamic interaction to address the timeline of the epidemic. Based on this point, I have selected the following data source to obtain the dataset for visualization. First, use media release of news or values as the main source of real-time data. Second, data are published in the official pages of the local government and the Ministry of Health, Labor, and Welfare. Third, dataset collected by other volunteers. Now let's actually take a look at the site. As with most dashboards, the four most important total metrics such as number of persons tested, confirmed, recovered, and deaths are shown on the top of the right. Extra like addictions and trends have also been added into the boxes. The main panel consists of map and table. The map of the left have two modes, simplify and details. Simplify mode is a static map, and detail mode is a dynamic map with timeline. And the right side is the mainly composed of three tables: infection, test, recovery, and death. User can choose to show or hide some indicator in the table by click the column visible button. And in the next tab, the user can learn the differences between real-time data and official data and those indicators of changes over time by province. In heat map or of infection, users have a very intuitive view of the daily growth and rate of increase in origins of the country. In the next tab, I use Gmap to show the number of confirmed in each region, support zoom in, zoom out moving, and other operations. In the domestic trends panel, I use the common bar chart, line chart, calendar to describe the development of the epidemic, such as confirmed trends in normal or log scale, the number of PCR tests, recover and death, and the correspondence of call center. There are also some features such as age, sex, visualization of the infect, progression of symptoms. In the next page, you can see how the confirmed cases are in fact to form a whole network. Hovering the mouse over the knot will highlight the patient's brief information, and click will display the patient's full information in the right panel. It's also possible to search for patients through the search box on the right. In addition, some features such as individual data, display page for each region, case map, analysis of Google community mobility reports are still being developed. If you have any question, you could just create an issue in the repo, and all interested parties are welcome to join this open source project. Thank you.
Very good. Thank you, Wei.
Thank you.
So I guess we can wait if a few questions come. And then we have Ben Phillips is actually back with his connection, so we can we will then leave the floor to him again, so he can finish. Okay. Oh. Okay. So Ben, you can come back on stage. Oh, of course, we now have some questions coming in for Wei, but again, we'll keep them in mind for the dedicated sessions. And here we have Ben Phillips. Welcome back. So you have.
Thank you. Thank you.
You have another 3 minutes. Okay, and you hear the bell.
Yeah, no, I'm not going to need that long.
Oh,
yeah.
Okay, cool.
I was so close to being done.
Okay, as you like. The floor is yours.
We'll try again. We'll try again. This is the second half, hopefully, very shortly. There we go. Okay. In the middle of saying that a wonderful has sprung up around this website, and it's really helped develop the website beautifully. There's been since it was first put out. We have state level drill down for quite a few now, a couple of forecast models. We're looking at we estimate undiagnosed cases that will be diagnosed but are yet to actually, and there's undetected cases which are cases that
Okay, looks like Ben doesn't have a very stable connection. We lost him again. Andrea, shall we move on to the last speaker? Yeah, he's dropped out again. Okay, I'm sorry. Okay, I'm sorry, Ben. We'll go to the last speaker and then maybe we'll try again. Sorry, the last speaker of this session is Marco Mingione. He's a PhD student in statistics at La Sapienza University in Rome. Marco, please come on stage. Yes. Oh, here he is.
Thank you, Manuela, for the introduction.
Welcome. I leave the floor to you then. Good luck.
Yes. So, hi everybody. I'm Marco Mingione, and I'm going to briefly introduce you to the to our Shiny app. I'm gonna share the screen. Close my camera. So, okay. This is an app built in collaboration with my colleague Pierfrancesco Alaimo Di Loro and the Stat Group team, and to monitor the spread of the epidemic in Italy. This app is daily updated just after the Italian Protezione Civile report, which is our main data source, and is composed of 4 panels. The first one is the overview panel, and I won't go into details, but basically gives general description of the epidemic. So in the first section, you can find the daily report with all the indicators. And just below it on the left, you have the help button with some useful information. I can switch to this, sorry. And you can also download the user guide. And I highly recommend this because it contains a lot of useful information for the full exploit of the app's features. Then you have the timeline of the ministerial decrees, which is very useful if you want to properly interpret the spread and the temporal evolution of the epidemic. And all the graphs are interactively, as you can see. You can also click on this and see the official document of the ministerial decree. And in this in this section, you can see the distribution of two of the main indicators, which are cumulative positives and current positives. And you can also switch to the regional level. While in this area, you have the temporal evolution and the spatial distribution of any of the indicators. And you can go back to the national level, and it's loading. And yeah, I think, yes. And you have daily variations, weekly variations, a lot of useful features. And here we decided to add ratios, 4 ratios, and with the fatality rate. And also here you can look the evolution at the regional level. At the end of the first section is with the raw data, which can be downloaded. And yes, you can go back to previous days, and you can move the columns for allowing a better comparison. The second section is said about the model. And here we provide short-term forecast for all the indicators. And the user can pick the indicator he wants, can choose the fitting interval. So you can exclude up to the last 15 days in order to evaluate at the same time the in-sample and out-of-sample prediction. And since the indicators are basically counts, we also have the possibility to choose between the negative binomial or Poisson distribution, which are the standard distribution to model this kind of data. And the assumption we made is that the mean parameter of both the distribution can follow a Richards or a mirrored Richards curve. And here you can also model by region and interactively see the forecast on the plot with the fitted and unserved values. And okay, it's a bit late, so I will move on to the ICU prediction. Here with an ensemble method, we provide a one-step ahead prediction for the ICU beds occupation in order to allow for an optimal allocation of the resources during the overcrowding of the healthcare system. And this tab is linked to a Dropbox folder, which is daily updated just after the Italian Protezione Civile report. And below it, you can compare the prediction of the previous days, any day starting from the 17th of March. Okay. The prediction column is colored in yellow if we expect that region to do better, and is red otherwise. The last.
I'm afraid we're running out of time, so
okay.
I need to interrupt, or you just get to the end.
It's just the last section is describes who we are. So you have the link to the blog and the Facebook page of the stat group. We also have an Italian version of the app. And yes, you have the link to the data source and to the GitHub repository. So I think it's all.
Thank you very much.
Thank you. See you later.
So we will try again to have Ben on stage, Ben Phillips. We'll see if we can finally see the end of your presentation. And just after that, we will have a small break. And here is Ben. Okay, we're really eager to listen to the end of your presentation. So
thank you. Yes, it's a 5-minute talk in 3 parts. I like to build the tension. It's all about building the tension. Right. 1 second. I'm getting very good at this. I've had lots of practice now. Waiting. Screen. Saying that we've been adding lots of things to it. And undetected case numbers. There's lots more that we'd like to add, but of course we're all working from home with children and doing homeschooling and lockdown, so that's really slowed everyone down. We've had, I guess the other thing about the site
it really looks like we can't see the end of your presentation, Ben. I'm sorry. I'm sorry about this. Okay, welcome back, everyone. So welcome to the second session of today's event. Again, we have 5 presentations, and we decided to move the schedule by 10 minutes. So instead of starting at 4:15 as planned, we just started at 4:25. So please note that this session will also end 10 minutes later than planned. Okay, the first speaker of this second session is Shubham Pandey. Shubham is a statistician who works in the advanced analytics team in Parexel International. Here he is. Welcome. I just leave the floor to him.
Thank you so much. Welcome everyone. I am Shubham Pandey and I am working as a statistician and economic modeler in Parexel International. I have extensive experience of working in R and R Shiny, and I have also experience of hands-on experience of working on machine learning and artificial algorithms. Let me share my screen. So this is the landing page of my application. It tells about like a bit about what is in the application and how you can navigate basically. So here are first four tabs where you can find the something about me, the app help page, and and this is the button to view the application in full screen mode. So this is the dashboard tab of my application. Here it is showing that the total number of countries affected, the total confirmed cases, and the bifurcation of the confirmed cases. Also, this is showing that what is the status of one day previous, so that you can find out how much increase today we have. On going down, this is the total cases of top 10 countries currently. You can also compare like the cumulative cases day wise, basically the active, the recovered, and the death cases. You can also plot on the latest confirmed cases like one day before. So when I click on this graph, we can see that yesterday Brazil has the highest number of confirmed cases. Similarly, you can plot on different graphs as well, like the deaths and the recovered. We can find that yes, the Brazil have the highest number of deaths as well. Moving on to this geospatial map. So here you can find out the total number of cases by hovering over a country. Also, the user can change this change this geospatial map based on the total recovered cases. So yes, so this is the graph of the total recovered cases. You can also find any country's information by clicking on that that country. Let's say I clicked on India, then I can find out the information of any of the India. We can select different dates, like from to which date we want. We can plot these graphs on the logarithmic scale as well. Similarly, we can see that what are the like how much the confirmed cases one day before. So moving downwards, here we have the data table, like the data that I have shown above. This is the tabular format of that data, and you can download this table either in CSV or in PDF, or you can just search any of the country that you want to see the result. After that, we have a comparison tab. Here you can compare how much, like the countries basically you want to compare. Similarly, you can select the outcome as well. The next one is the forecasting tab. So here I have used the infectious disease modeling, the SIR approach, to predict the total number of cases or the pandemic height. So you just have to select the country from here, and then it will predict the pandemic height and the deaths and the number of cases. You can specify of anytime this. You can select the date till which you want to forecast. I have also added a sentiment analysis in this tab. Here,
I'm afraid you're running out of time. If you can please go to the end.
Yes, sure.
Thanks.
Yes, sure. So this is the sentiment tab. This uses natural language processing to extract the from Twitter using these hashtags, and this is the word map basically. Here we have the graph of the different sentiments. So that's it about my app. You can find this on the CovidR contest page, as well as you can find it on my personal website by clicking on this name, Shubham Pandey, or by clicking on this about developer page. Thank you so much for listening.
Thank you very much, Shubham. That was very interesting. Okay.
Thanks.
We can go to the second speaker of this session, and it's Emanuele Guidotti. He's a PhD student in empirical asset pricing at the University of Neuchâtel in Switzerland. Welcome, Emanuele.
Thank you for the introduction, Emanuela.
You are originally from Milan, right?
Yes, I'm originally from Florence, and I've been studying in Milano.
Okay, then the floor is yours.
Thank you. Just let me share the screen. Okay, it seems to work. Welcome to COVID-19 Data Hub. The World Health Organization identified key open scientific questions to tackle the epidemic, including socioeconomic and behavioral risk factors, transmission dynamics of the virus, role of the environment, susceptibility of populations, effective policy measures. No doubt, COVID-19 data are immensely useful, but unfortunately, they are released by heterogeneous data sources in different languages in several formats, and are hardly accessible to the average researcher. The goal of COVID-19 Data Hub is to provide a unified, easy access to worldwide fine-grained data. How to do? We implemented an R package designed to aggregate the data from several sources. We put effort in making everything open source and easily extendable. We need native speakers to search for local official data, understand the data, and integrate the data in the package. We had people from India, Poland, Russia, Sweden, and more collaborating on GitHub. The package is exploited by a dedicated server, which downloads the latest data and makes them available on a cloud storage on an hourly basis. These are CSV files that can be used by any client application. The files were downloaded 33,000 times in the latest 48 hours. We implemented out-of-the-box clients to easily retrieve the files. First, the COVID-19 package on CRUN. This is not the GitHub package we use to aggregate the data. This is the CRAM package available to the end user to retrieve the data from our cloud storage. To respect the terms of use, we cannot store World Bank, Google, or Apple data, but we can provide additional arguments to download such data and extend our dataset in real time. We're now implementing a similar client for Python. We published a quick article on Towards Data Science where we show how to quickly build data-driven Shiny apps using our package. Simply connect the Shiny inputs to the COVID-19 arguments. The function uses an internal memory caching system so that the data are never downloaded twice. We do our best to guarantee the data quality and consistency. We keep track of each source for each data. We generate an error log that already spotted 3,000 misalignments in the official data. We rely on the open source community. Everything is open source, code and data. The bigger the community, the faster possible bugs will be notified and fixed. We also offer vintage data, daily snapshots of the data, so to ensure research reproducibility. Our dataset includes standard COVID-19 variables, policy measures by Oxford COVID-19 Government Response Tracker, geographic information to easily plot on a map for data visualization or merge with external databases. For example, weather information, geolocated tweets, etc. Finally, we provide external identifiers to easily extend the dataset with World Bank Open Data, Google, and Apple mobility reports. Governmental identifiers are also provided to further extend the dataset with local fine-grained statistics. For example, for Italy, ISTAT identifiers have been implemented. We support 193 countries. More interestingly, we support 500 regions and almost 4,000 cities. But they correspond respectively to 18 and 5 countries. I would like to take the opportunity to ask you to join the mission and support new data sources. I would like to thank Hack Zurich for the support in the very early stage of the project, the Canadian Institute for Data Valorization that is funding the project, and all the volunteers who have joined us. Thank you.
Thank you, Manuele. As we still have a couple of minutes, I will ask you a question that I'm just reading from the events chat.
Yes.
Federico Marini is asking how often did it happen that data providers change their data format, and how brutal was that change?
It happens very, very frequently, especially in March. Then things started to become a bit more stable in time. Usually they do not make huge changes, but when you are aggregating data on a programmatic level, even a comma can break all the code. And so we are implementing automatic testing exactly for this reason. What they do change on a daily basis are historical data. So it does happen that they do change the numbers of cases of deaths in the past. And that's why we offer vintage data to keep track of that.
Okay, that's a very big project. Thanks.
Thank you.
Okay, so I would just like to remind you that at the very beginning of the, to remind everyone that at the very beginning of the chat, of the events chat, there is a message pin, and there is the link to all the projects that were presented today. So you can go and browse the apps and also vote for the one that you prefer. Okay, so we can now go to the third speaker of this session. We have Alberto Danese. He's head of data science at Nexi, and he works and lives in Milan, I guess. Is that right?
Excuse me?
You work in Milan, right?
I work in Milan. Yes, I do.
Okay, yeah, just as I mentioned Italy just before. Okay, the floor is yours.
Thank you, Manuela. It's a pleasure for me to be here today in this virtual conference. Let me just share the screen, and I will introduce my work. Okay, I guess you should see it. Well, so far I've seen a lot of amazing dashboards, amazing packages and studies. I chose a completely different approach, actually, because I think there is you know, what they call an elephant in the room, that is the reliability of the official data that we are working on. And I refer specifically to the number of infected people and the number of deaths for COVID-19. Because there is a huge problem that different countries and different regions and cities do not have the same procedure and the same policies for testing people for COVID-19. And as a matter of fact, it's very difficult to compare this data, and the number of infected people does not particularly reliable as a number. Just as an example, in Milan, we have officially 0.7% of people who tested positive for COVID-19. But if you take a look at the antibodies test, there is roughly 10% of the population that has tested positive. So I decided to take a completely different road, and I decided to download the official data of overall death trends in a historical time series that goes from 2015 to 2020. And they made a simple.
Sorry to interrupt, but it might be better if you leave your screen shared only. Okay.
All right. Okay.
Sorry about that.
And so I decided to download the overall death trends from 2015 to 2020. Well, it turned out I made a simple assumption that in a large enough area and for a large enough time frame, the number of people dying every year should be more or less the same, unless there is a specific event going on. And as you can see, there is really no need to do some statistical test, because this is the province of Bergamo that has roughly 1 million inhabitants. And it's a region where, it's a province where usually every day 30 or 40 people die, while this year in March there have been up to 250 people dying every day. So it's been really terrible. And this proved my approach to be quite consistent. And I could do a lot more analysis. For instance, I studied the different age groups. And again, there is a narrative on the newspapers that tells that COVID kills mostly elderly people over 70. And while it is true, I mean, you can see here some figures that you have probably not seen elsewhere. Like, for instance, the impact on people in their 50s and in their 70s. Just let me highlight a single line. People 56 to 60 in this particular province in Italy, you know, on average, 6 people die in the second half of March. And in this year, there have been 54 casualties. So 8 times as much. That is really terrible, but it gives us an idea of the real impact of COVID-19. And well, I've done a lot more analysis on age groups and on gender differences. And for sure, females are less affected by COVID-19 than males. But again, these are some actual figures that are completely unbiased because they are the overall death. So not only people who get tested for COVID, that is unluckily just a small portion, a tiny portion of people who actually got COVID-19 in Italy. Well, again, you can see some figures and see what was going on in Bergamo in the second half of March. It's really been terrible. I made some comparison across Italian provinces, but I'm just keeping it for reason of time. But for sure, if you want to see something more fancy, I downloaded the official Italian files, and you can see, for instance, that in the city of Bergamo, usually 50 people die in the second half of March, and this year 400 people died. So that's 8 times as many. And let me quickly jump to the conclusion. I wanted to do something animated to close this analysis, and I played a bit with the GG Animate, that is the package to animate GG plots. And here you can see how the situation in Lombardy evolved. It all started in Lodi, this province, hello, and then quickly it moved to Bergamo, and it became black in the second half of March because the number of people who died in Bergamo were 9 times as many as usual. So it's been really a terrible impact. So that's about it. I think it's important to focus on the quality of the data and on the reliability of the data as well as on the part of the analysis. That's why I propose this different approach. Thank you.
Thank you, Alberto. Yeah, I really appreciate this approach. I'm a statistician too, so I really appreciated it.
I'm glad you liked it. Thank you.
Okay, so we're running out of time a bit, and as usual, you can ask questions. I mean, as I said before, you can ask questions in the dedicated session, the speakers lounge, and you can also share your video. So if you, as a participant, as an attendee, you want to ask a question, you can actually share your video too, which would be a nice way to be able to interact a bit more. I now call the fourth speaker of this session, who is Angelica Becerra. Angelica is a statistician at the KOF, Swiss Economic Institute of ETH in Zurich. Welcome, Angelica.
Hello, good afternoon.
Hi, the floor is yours.
Thank you. Hello, everyone. My name is Angelica. I'll let me screen. Okay. Good afternoon, everyone. My name is Angelica Becerra. I'm going to present Trendicon. This project started as a collaboration between economists, programmers, and statisticians during a hackathon 2 months ago. During this extraordinary time, economic conditions are changing extremely fast. So official economic statistics are usually released with a considerable lag. For example, the consumer sentiment index, GDP, or private consumption data become available with a lag of up to 3 months. For decision makers, this might be too long. So our solution is to use Google search trends to provide a set of timely economic indicators available on a daily basis. The idea is that people's searches on Google tell a lot about their perception of the state of the economy and demand for certain products and services. For example, here you can see Google searches during the last year in Switzerland about 2 specific words. So what we have at the moment, we have a set of indicators, we have an R package and a website. How do we do that? This, you can see our main indicator and the perceived economic situation compared with the GDP for Switzerland on a quarterly basis. So we selected some keywords. We got the data from the Google API, then constructed indicators using PCA and compared them to existing economic indicators. It looks quite simple, right? But there are some challenges. We have sampling issues because when we got data from Google API, the result depends on the time window you're looking at. For instance, these are the results for the word insolvent. So when we got the data for the last 5 years, that is the line in black, we don't have the same result when we ask Google for results since 2004. Sorry, since 2004 is black line, and you can see that the blue line, that is the last 5 years, is quite different. Another issue is that Google doesn't provide daily or weekly data for long time periods, and we want data ideally from 2016. So how can we solve this? Well, given time constraints, you can check methodological section on our website, but we also created the R package Trendicon, so work in progress. Currently in the package, you can find the code to construct long daily time series from Google Trends. We query Google API multiple times to have robust data. However, that might be a problem when you have many, many words. Queries are sampled at different frequencies and combined preserving the long-term trend. The download itself relies on the gtrends R package. You can install it with the function install GitHub on the remotes package. As a short example, you can see here the keyword cinema for Switzerland, and by default it show us the last 5 years. One important remark that with Trendicon package, you won't get the same results when you query more than 2 words. For example, these are searches for kino and theater using gtrends-r, and the result we got for theater are rescaled based on the searches for kino, which is the word with the highest point during the last year. With Trendicon, you can independent downloads for each keyword, so we can construct easily our indicators. And this is important because when you query words that have huge popularity, then you might end up with many zeros. As you can see here with the words kino and insolvents, where insolvents basically has 0 for the whole time period, using the package gtrends. When you have independent downloads, that's better. Construct the indicators. So with the Trendicon package. And finally, you can find all the indicators, the data available online, and the R package in our website, trendicon.org. By the way, this was developed using Flex Dashboard, so you can go and check it out. And yeah, thank you all. That's it.
Thank you very much, Angelica. If you have questions for her or for the previous speakers, you can ask them in the either in the chat here, in the events chat, or on Slack, in the dedicated channel, and then we will ask them in the speakers launch. So we do have a few questions for the previous speakers. Actually, as I said, there is a bit of delay, so we often get the questions a bit later, but we will have time to discuss them in the speakers launch. Thank you, Angelica. We will see you there. I will now call the last speaker of this session, who is John Cohen. He's data analyst at the World Economic Forum in Geneva, Switzerland. Please, John, you can come on stage. Okay, here you are.
Hello, I'd assume.
We hear you and see you. So the floor is yours.
Thank you very much for the kind introduction, Emanuela. I know we're running out of time, so I'll be really brief. I'll switch off my camera and start sharing my screen real quick. Goodness fella. Application window. Let's just share that. Sorry. Something went wrong. Looks like I can't share my screen. Can you see my screen now?
No, we can't see it.
I'm afraid it's not working. Apologies for that.
Maybe you can try. If you want to try one more time, and then maybe we can go to the sessions first, to the speakers launch first, and then come back, and you will be the first.
Is it working now? By any chance?
Yeah, it's working now. Perfect.
Oh, lovely. Okay. Goodness me. Great. Thank you for your patience. Yeah. Well, I wanted to be quick. It's not going to be, but essentially, I've just checked. The first commit I did on this project was back on the 1st or 2nd of February. Essentially, I lived in China 5 years. My wife is Chinese. So when I saw this whole coronavirus, it wasn't even named yet then. Since I had a connection with the country, I wanted to look into the data. And at the time, at least, the only source of data I think that was readily available was Johns Hopkins data, which in hindsight now is actually not the best and most accurate there is out there, but that's what I had at the time. And then the idea was to build an open source dashboard. Let me switch off my camera. An open source dashboard where which one could download, install, and deploy themselves. So it had to include a small snippet of code to crawl the data, check that into the database, and also added an API later on. So here are the overall numbers for the 3 sources of data that I used. So it's not exactly Weixin here. It's more as Tencent. They had a tracker, and then Ding Xiaoyuan, who also was tracking data on China. So here, essentially on the first tab, Johns Hopkins, you see pretty much what you can see on the Johns Hopkins dashboard. I had to focus on the China map here, which you could see, again, the evolution of it over time. I'll just show you briefly. Let me stop that briefly. This tab, which is probably was at least at the time the most interesting one, because it looked into China specifically, and the idea was that the Jingxiaoyuan was providing the data at a quite granular level, so you could select a province of China and get the breakdown by city down here. And by the way, there is something I'm failing to mention, is the fact that I'm using the Shiny mobile framework for this, which essentially looks much better on a mobile. So if I try and force it on a mobile, yes, like this, this is how it's sort of meant to look, essentially. And it provides you with, say, cards like this, which are, if you use
Okay, welcome to the third session of today's event. Again, we have 5 speakers. So the first speaker is Peter Laurinec. He works for a startup called PowerX, and he holds a PhD from the Informatics and Information Technologies faculty at the Slovak University of Technology in Bratislava. Peter, you can come on stage and share your video and then your screen.
So hello everyone. Yeah, I can just...
So I just hand you over to Peter.
So hello everyone, I am Peter Laurinec, and I will present my dashboard, Corona Dash, that is a clustering analytical tool for comparing countries' COVID trends. My first idea to create some dashboard was by some very interesting tweets by academic forecaster Fotios Petropoulos that created forecast by exponential smoothing for aggregated world cases. So my idea was to do it interactive and for every country. So this is my dashboard for this use case. So for forecasting at, for example, 10 days. So I can choose, for example, Italy, and I can see of the COVID-19 and the like a simple extrapolation of cases for cumulative cases. I can set the days, for example, and I can see longer forecasts. My second idea was inspired by Joe Murdoch tweets. He's like a Financial Times reporter, and he made really nice charts or visualization of COVID-19 countries' trajectories. And so I created a dashboard for it to have it fully interactive again, to play with the statistics. So here it's like his implementation, interactive implementation of really nice charts. So I can choose like other countries to it, and various statistics also computed by per 1 million population, and you can interactively compare countries' trajectories, like since first 10 case, yeah, and also with classical timeline. Okay, my last idea was to involve somehow my knowledge gathered from my PhD and work to cluster time series. So in this case, so COVID-19 spread trajectories. So I'm using hierarchical clustering with dynamic time warping distance to cluster like large number of countries' trajectories. I can again choose various statistics and cluster countries, top n countries trajectories. So I can set, for example, more countries to cluster them, and I can see plot of nice trends like decrease or increase or stable are countries of fighting the disease, right? And I can now maybe search the country, like where is now US, for example. Yeah, and we can see that it's like more stable, or I can choose, for example, the more increased trend countries and to search them also. I can see also similarities between countries by dendrograms or multidimensional scaling plot to see the connections between the country's trajectories. Okay, I have, so this was my use case of clustering. I also clustering of last updated statistics in the dashboard also, so I can pick multiple statistics. For example, I can also cluster the new trends, so the last updated, so from yesterday, new cases and new deaths, and clusters this data. Also, I can pick, for example, more countries to cluster and to see the connections between countries. So, for example, my country Slovakia is in the cluster of Poland, Romania, etc. And I can also check, for example, the cluster members' averages. So every cluster has its average. So I think that's all that I wanted to present. Thank you.
Okay, thank you very much, Peter. We really did get many different contributions. I'm quite happy, and so were the main organizers of this event with all the submissions we got. Thank you very much, Peter. So as usual, you can write questions in the Slack channel or in the events chat, and then we will try and start from those during the Q&A sessions at the end of the 5 presentations. So I now call on stage the second speaker of this session, who is Eric Wanjao. He is undergraduate student at the Dedan Kimathi University of Technology in Kenya. And I should also add that he was actually awarded with a travel grant for the ERAM 2020. Then unfortunately we had to cancel all travel grants, but we are happy that he still can contribute to this event, to ERAM 2020, and that we can, I mean, we get to meet though virtually. Okay, so I leave the floor to Eric, and thank you for being here.
Hello everyone. Hello everyone. So my name is Eric, an undergrad student at the Dedan Kimathi University of Technology. So here is my presentation of the COVID-19 cases in our country, Kenya. So welcome to a presentation, and I'm so grateful to be here. Just a bit. So my first tab features like a little summary of all of what is happening in our country related to COVID-19. So I chose to implement this using a Flex dashboard. And here, as you can see, I decided to use some value boxes that show in our first tab all the cumulative number of tests conducted, the number of cases in the compartments of people who are confirmed, people who have recovered, and people who have sadly succumbed, and also the total active cases. So I felt this would give a brief and tidy, view of someone who wanted to look at our data as a country. So next, I implemented a small interactive chart here that shows how the cases have been going on a daily basis, and also decided to include some markers, such as when the curfew started or when we implemented lockdown in certain areas of the country, and as such. And also right here on the right, there is a gender distribution pie chart, which shows the extent of the COVID-19 cases gender-wise. So next, on my next tab, I decided to include a daily count. So here I decided to focus on the number of cases that are reported on a daily basis. So the cases in the people samples tested, people in the 3 compartments of being confirmed, recovered, or succumbed. So here I implemented a small trend line. So each compartment of cases had two line graphs each. So one showing the cases per daily basis, and also a small moving average, to show how the trend of the cases in our country are going. So also decided to include a small data table here, DT table, that shows the entries in the last 5 days, as you can see here. So that was it for this tab. This was just focusing on a daily count of the number of cases. So next, I decided to go deeper down in the cases and look at the cases per county level. So he also implemented the normal value boxes, but what is interesting here is an interactive map where shows the number of cases in each county. One can just hover. The county where I am in is Nairobi, has the highest number of cases. So the purpose of this dashboard was just going deeper, seeing how the cases are distributed per county, and to here a small data table that shows the number of cases that have been reported on this day, and the number of cases cumulative for that county. So it's also noteworthy also the number of counties that have had the infection. So that was it for this tab, just focusing on the counties and their respective cases. So I went ahead with the help of Team Churches and I'm trying to implement a safe model, which just a naive way of projecting the cases if people had not followed the directives followed by the government. Also in this tab, the next tab, I decided to do some Africa statistics, just comparing our country Kenya and some of the countries in Eastern Africa, and a nice maybe interactive table here where you can search the cases per country-wise. So this was just merely focused on Africa, just a brief view of Africa. And lastly, the global statistic, just a nice cumulative seeing how the pandemic is in the whole of the world. So this was just interactive map showing all the cases in the world. So just decided to include the protective measures, for guidance from the WHO, and that was it on my part.
Eric, I'm sorry to interrupt. I have to ask you to wrap it up.
Yes.
The end. Thanks.
Nice. So I was just thank you. I was just at the end. So this is the end of the dashboard where I I try and give a brief overview where I got the data and the contributions, especially from Team Churches and Antoine. So that was it for me. Thank you. Thank you so much for listening to my presentation, and happy to be here. Keep safe. Thank you.
Thank you, Eric. Thank you very much. Okay, we now will move on to the third speaker of this session, who is Ilaria Ceppa. Ilaria is a senior data scientist at Kobi Solutions. Please, Ilaria, you can share your video and your screen.
Hi everyone.
Okay. The floor is yours.
Thank
Ilaria.
you. Hello everyone, I am Ilaria Ceppa from Code. Code is a data science society that operates and is based in Italy. With the spread of the coronavirus in our country in late February, we also wanted to make a visualization of data on the virus that was which aimed at being the simpler and clearer possible. For this reason, we looked at the data that was available at the time officially, which was the data from the Protezione Civile Italiana, that every day publishes updated data on the total cases and the hospitalized patients in Italy. The dashboard we created was made in Shiny, of course, and is based on the framework BS4-, and uses interactive charts made with Plotly. The first screen of the app shows an overview on the situation of the entire nation. So on the first line, we have a clear indication of the total number of cases, the currently positive patients, the intensive care patients, and the deceased one. The charts below are an immediate representation and visualization of the situation, the evolution of the situation during time. So we can see the evolution of both the total cases and the total positives. And on the right, we can see also how the number of quarantined people increased until May and started to decrease finally after May. Below, we used a representation of the increment between days. So for all the variables we had available in the Protezione Civile data, we computed the percentual increment. So we could provide an idea of how the situation was evolving. So for example, if we look at the total positive number, we can see that we started going in a decreasing trend from some time now. The chart on the right represents the same kind of information, so it's always a percent increment, but it's shown for all the regions in Italy through an heat map. So the value of the percent is mapped to the color of each tile. Finally, the two charts below are a geographical representation of the values of the number of total cases, the hospitalizations plus the quarantines, and the comparison between the total cases and the new positive made on a logarithmic scale. This chart helps to to see whether the situation is improving or not. Because when we were in a growing, in the growing stage of the pandemic, the chart had this linear trend, whereas now that we are in a descending phase, the number of new positive is very, very much lower with respect of the number of the total cases. So I'll be very, very quick. We also have a very similar page, but with the drill down for each different region. So with this select box, you can choose a region and see the data for that specific geographical zone. And in this other chart, in this other page, you can compare in one single view all the regions in Italy and have at glance a view of all their trend values for a selection of the variables. In this chart, we used mainly three colors. With the red, we indicated values above the mean, in blue, values below the mean, and in black, values that were average. So,
to ask you to go to the end of the presentation, please.
Yes, I was mainly done, so that's okay.
Okay. Okay. Thank you very much, Ilaria. Sorry for interrupting so brutally.
No, don't worry. Don't worry.
Okay, so
thank you.
We'll have time for questions as usual at the end of the. And now I invite Nico on to take the floor. Nico is a graduate student at LMU in Munich. Here is Nico. Welcome on stage.
Thanks for the invitation.
Thank you for accepting. The floor is now yours.
Cool. I will share my screen.
Yep.
All right. So a lot of people are doing dashboards about coronavirus, and I wanted to do something a little bit different. So a few months ago, I stumbled across this Wikipedia article that lists what is happening on what day. And this is basically what this app is all about. It's about showcasing the timeline of coronavirus, how the pandemic started, how it spread, and what it looks like now. So as you can see, you just have to scroll through the app, and then text snippets will appear with the data above. And from time to time, there will be some graphs in there, but overall, it's pretty long. I'm continuously updating it with new facts and plots. So if you want to scroll through it, it's taking some time, but you can also just go to a specific chapter and then you can read it in multiple sessions. And it goes up until today, I think, where you can see statistics of today. And these are automatically updated. So every time you start the app, it will have the most up-to-date statistics, depending on when the last data was available. And in addition to all of this stuff, there's also this map right here with leaflet, which also shows the current data. And you can click on specific countries, so you can see how the data looks in one country only. You can also adjust the date range to see how it's within a certain span. And here you have the daily numbers and the daily deaths. And yeah, that's pretty much it. I tried to keep myself short since we're already behind schedule, and I feel like there's not that much to show in my app since it's much of the same. And so you probably should just explore it for yourself.
Okay, thank you. Thank you, Nico.
You're welcome.
And yeah, there are actually different ways to interact with the speakers in case you want to reach out to them. And in addition to the dedicated sessions for Q&A, you can also click on people, like in the right in the right panel. You see people, and then you can click on the people, and you can easily interact with them in case you want to have like further conversations on their presentations. So I now invite the last speaker to take the floor. And the last speaker is Michele Stefano Altieri. He's data scientist at Hyperminds. Okay, here
Hello.
we see you, Michele.
Everybody. Thank you, Manuela.
Thank you.
And all your opportunity. Okay, I'm Michele Altieri from Hyperminds, a data science company, Italy-based. Okay, just give me one moment so I can try to share my screen. All right. Okay, so actually, when we at Hyperminds developed our COVID-19 dashboard, we would never have thought one day to present it. So what we have done is to create our own COVID-19 package in order to retrieve and analyze the outbreak and spread of COVID-19 in Italy. We love to work with R6 classes. That's why we end up building a COVID-19 object that is able to acquire data, analyze it, and create nice representations. We are retrieving data from the Italian government official repository, and we developed a Flex dashboard app, that is the one you are watching, using eye charts plot in order to represent the evolution of the phenomenon. In the plot on the left, we have the actual data. Now we have a lot of data, but it's not the same at the beginning of the phenomenon at the beginning of March. And we created the app actually at the end of February when the first data were made available. And at that time, it was very difficult to understand the rate of growth of the infections. In particular, we had no idea of when we would have reached the peak, and everyone was freaking out trying to figure out when it would be all over. And that's why we decided to create something different, okay, and to add a predictive model to our dashboard. We developed an SIR very basic model, but we used time-dependent parameters. In fact, we realized that, especially at the early stage, the reproduction number and all the other parameters were changing very fast. That's why a static model wouldn't have had a nice predictive power. And here in the dashboard, you can see the parameters and the evolution of the parameters of our SIR model. As you can see, the reproduction number is now 0.15. And below 1, but it was not that level in the past weeks. And through the dashboard, we could have the opportunity to monitor the evolution of the parameters, and that's what we have done in the last few weeks. Moreover, here in the main panel, we add a date selector. Here on the right, you can see the results of our predictive model. And with the date selector, every user can feed the model at a specific evaluation date. This way, it is possible to compare actual data with the one predicted at a certain point in time in the past. The difference between forecast and actual data depends on several factors. We may have, of course, model error, But through a daily basis monitoring, we are also able to estimate the effect of the lockdown here in Italy. Anyway, what we obtain is an error under 3% in predicting the active cases of the following day. For example, I can choose a date in the past, maybe at the beginning of April. And what we can see is that the peak of the infection, which actually happened around the 20th of April, was quite well predicted even in the previous days. So if you like the dashboard, it's public accessible, so you can go and use it and browse it. That's it.
Okay, thank you very much, Michele.
Thank you to you all.
So these were all the presentations for this last session. So you can find the last 5 speakers in the speakers lounge. So I invite you, Michele, and all the others to go there. And at 6 p.m. we will start the awarding ceremony, where we will give prizes to the to some of these apps that we saw.
Be up to the task. I will take this time to recall a bit about IRAM, the IRAM conference, and tell you how this conference is organized. The conference will be from the 17th to the 20th of June, and the hackathon, which is another satellite event like the one that we have seen today, will be on the 16th of June. I will share my slides very quickly. You have seen.
Yeah, Mari, and if you can keep sharing them while I announce the winners, that would be
okay. Yeah. So I will do. Yes, I will do this job. Okay. So I guess you can see my slides. Okay. So as I told you, the conference will be organized in 6 tracks. So the contents, both from our keynotes and invited speakers, but also from the contributed speakers, we had really lots of submission, and we selected about 100 contributors. Will be organized in 6 topics. So the first one is data visualization and Shiny, and Sharon Macalis, which is a data journalist, will be the keynote speaker in this track. And then we will have Jaron Lander from New York to talk about our application. Thomas Calibera, which is part of the R Foundation, will be our keynote speaker for the track R World, which is all about R and R developments. Then we will have Kelly O'Brien from R Studio for R in production. So everything which is related to R at scale, to infrastructure and everything. And then we will have Francesco Bartolucci for machine learning and models. He is professor at the University of Perugia. And then Stephanie Hicks for R in life science from the Johns Hopkins University. These are our invited speakers. So they also are linked to a specific track, and all the other contents, the poster, the Shiny demo, and the parallel sessions, so long talks and lightning talks will be organized around these topics. During the conference, we also have some repeating sessions. So if you want to be if you want to propose your candidates to one of our sponsors, then you can fill a form which is included into the registration page to leave your CV, and there will be also dedicated sessions during the conference. The Q&A areas will work as you have seen today. I think they were very great. So we will have questions during the talks, but also dedicated moments where you can interact with the speakers after each session. So what else? Okay. The other contents that we will have will be the workshop from very a big variety of topics. So we will have workshops about machine learning as well, about R in production, so how to use Shiny or how to use GitHub at the best, or also how to implement HTML widgets. I think that there's really a big variety of workshops, and they will be 10 workshops divided into 5 in the morning, 5 in the afternoon on Saturday 20. The hackathon about special networks is another satellite event of this conference. It will be on June 16. And you can register from a separated registration, separated ticket, but you will find information in the registration page. And yeah, so this is the calendar. Today we are in the CovidR pre-conference event. We actually decided to add this event when we decided to move the conference in its virtual version. And we thought that it would be interesting to see the contribution from all our community about coronavirus. So this coronavirus was hitting our lives so strongly, and so we thought it would be nice to engage everyone around this topic. And we were very, very surprised and happy to see how many of you decided to submit contribution and to participate, and it made the task of selecting some for the presentation very hard, and even harder now to select the winners. So if you still have not registered to IRAM, please go to the registration page. We really hope to have you there again. And the registration are free, so we were able to have the IRAM event as a free event, thanks to our sponsor mainly. So I really want to thank them again. It's possible for you to leave a free donation if you want, but it's not mandatory, of course. And the free donation can support our association and all the events that we are organizing. Where else? I don't know if we are on schedule right now, or if it's better to wait a little bit. Do you know, Emanuela, how we are? Okay. So maybe we are quite close to the.
I think we can maybe just announce the winners now. I would have liked Ricardo to be able to come back, but apparently his connection doesn't allow him to. I'm sorry, because I think it would have been nicer from him, as he was one of the minds, the initial minds of today's event.
I really want to thank again his work, the work of Riccardo Porreca, Francesca Vitalini, Andrea Guzzo, Andrea Meloncelli, Roberta Sirovic, Emanuela Furfaro, Federico Marini. There are several people behind all this event, Mirko Signorelli, and all of you, all the organizing committee of this, that the big IRAM, we are working since last year for the big conference, and so it's so great to see that everything is happening actually, despite of the coronavirus epidemic. Okay. So maybe we are ready.
Maria Chiara, you can keep sharing your slides. I mean, they're the same slides, so
okay, just one
you can
second.
just leave those on.
Yeah, I just go.
Because for some reasons I can no more share the slides. I mean, I had it ready before, and then
okay,
as you showed yours, it disappeared. So
okay.
Yeah.
Okay.
Okay. Okay, so we will announce, we will call on stage 6 different people. First of all, we should say that those 15 that presented today were all finalists. And then we'll announce the two winners who will receive the book signed by the author, and also they will be invited to present their work at the actual IRAM 2020 conference in mid-June. And then we have 4 more winners, 4 more awardees. 2 were, let's say, planned, and then 2 others we decided to give 2 extra prizes thanks to our keynote speakers who offered to send their book signed by themselves, that they're the authors. Okay, so the first prize that we the first 2 prizes that we announced are the first 2 awardees that we announced are the 2 that we were allowed to award thanks to our keynote speakers. The keynote speakers who who were available to give us their book signed are Sharon Mackless and Jared Lander. And so let's start with the book by Sharon Mackless, and this award. So we decided to give this. I don't know how to announce this, the winners. It's the first time I announce winners. So the prize goes to Eric Wanjao for his work on data and topics which are typically underrepresented by global media and journalism.
Okay.
We invite Eric Wanjao on stage. You're already on the backstage, so you can just ask to share your video and your audio. So if you'd like to say a few words like how your journey with R started, and what brought you to submitting this contribution to the contest.
Okay, we'll see if Eric can join us for a while. Okay.
Okay, then maybe we can announce the second winner and then we just call them together on stage.
Yeah.
Okay. Okay, so the second, let's say, extra prize that we were able to give was the book signed by Jared Lander. And we decided to give this award to Weisler for his massive work with various sources of data and major and complete visualization dashboard. Applause. And then we also call Weisler on stage.
Oh, that's so cool.
Thank you.
So yeah, if you just want to say a couple of words on how your journey with R started and why you decided to submit to this contest, yeah. Just like a 30 seconds thing.
Yeah. I just made this product, and that's why I submit this work to this conference. That's all.
Okay.
Okay.
And how did you find out about the contest and the conference? I mean, you had been following IRAM 2020, or?
Yeah, I just follow John, and I have seen him submit his work to this conference, so I followed him.
Okay, thank you very much, Wei.
Okay.
And congratulations again.
Thank you.
We were also very surprised that people from all around the world actually submitted contributions, so it's so great. Thank you.
Thank you. Thank you.
Okay, so we now can call Eric back on stage. He says he's waiting for approval on stage.
Yeah, so let's see.
Otherwise, we're
It's
just
approved.
going to... Okay, he's been approved, so he should be on stage soon. Yeah, let's keep the others waiting. The other.
Yeah, it's very thrilling.
So the book will be sent straight to you by the authors. Yeah.
So we'll just need the address where to send it.
Yeah.
So, yeah.
We will reach out to you and get the address and all the information our keynotes need to send the prize.
Yeah, I think we can move on the next, and then maybe call Eric later.
Okay. Then we have the two. We call them honorable mentions. So they're not the actual winners of the competition, but still, we still decided to give them the prize, which is in this case a book, the book Alpha Data Science, signed by Hadley Wickham. This was offered by RStudio, and the two winners are Angelica Becerra and Ben Phillips.
Okay.
And the applause. Okay, so you are also welcome on stage, Ben and Angelica. And if you'd like to, we would like to hear how you started this project, or maybe some of you already did, but how you started and why you decided to submit. Hi, Angelica.
Hi.
Congratulations.
Sorry, could you repeat?
If you could just say like a couple of words, just how you started this project and why you decided to submit.
Okay, we started this project like 2 months ago in a hackathon here. We knew about this because one of the main contributors of all this project, that is Christoph Sachs, told us about this event and pushed us a little bit to move on many things and to submit our contribution. So, and thanks to all the team that contributes a lot on this project.
Thank you for submitting and for contributing to this event and to this content. Thank you very much. So you will also receive the book signed. We will reach out to you to have your address, and then the RStudio will send it straight to you.
Thank you very much.
And if Ben is still here, we can also call him on stage. Otherwise, we'll move on to the actual winners of this contest.
Yeah.
Okay, right. So hopefully we can have Ben on stage.
Yeah, we can try.
With his connection.
Yeah. Let's do another attempt.
Okay.
Oh, yeah, great.
Hey! It worked. Thank you very much. I'll be quick because no doubt my connection will just stop randomly. Thank you very much for inviting us. The main reason we built the app was really we felt very strongly that we might be able to help in some way by showing people what was coming. So that was our motivation for building the app. This is just nice. So thanks.
Thank you for submitting and for staying up late.
Yeah.
Because I guess it's now, I don't know, 3 a.m.
Yeah, something. No, it's 12. It's the 12:30 where I am. It's a big country. I'm on the other side.
Okay, cool. Thanks.
It's been a pleasure to be a part of this. So thanks.
Thank you.
Thank you so much. How long was it?
And we have Eric now on stage. Yeah, so yeah, if you want to say a couple of words on how this started and how you decided to submit.
Hello, Emanuela, and everyone in the ERAM committee. So I'm so happy. Thank you so much. So happy for this opportunity. I would say the main motivation was there was not really a central, maybe repository to view the COVID-19 data in Kenya. So I decided to take up the challenge, mark my 365 days since I wrote my first article, and I didn't in the wildest dreams I didn't expect it to be presented. So I'm just so thankful to ERAM and the whole art community, and yes, looking forward to greater events by you. Thank you so much.
Thank
you, Eric.
Okay, we can now announce the winners of the contest, and so we have two winners, and I will call them by the presenter, although it's a bigger group. And these two, they will receive the Afro Data Science book signed by Hadley Wickham, but they will also be invited to present their work at the ERAM 2020. So we're still preparing the schedule, and we will reach out to you to see when it would be best for you to present. The two winners are Mark Hanley and Emanuele Guidotti. Sorry, okay, here.
Emanuela, thank you so much. I am very, very happy. Very, very happy about it. And
yeah, so hopefully you'll be able to come to the. I mean, we're inviting you, so hopefully you don't have something going on those days already.
Yes,
and,
all right.
You can join. It will be from June 17th through June 19th. So yeah, we will reach out to you to
Great.
see what's the best slot for you. And you already know how to use Hopping, so it would be easier to train you as a speaker.
Yes. Can I thank a couple of people I would really like?
Sure.
First, I would love to thank David Ardia, because this project actually started at an hackathon. I developed the first prototype, but then he saw something more in that. And it's thanks to him that we managed to have a community around the project and to build something that is hopefully useful for a better understanding of the virus. And second, I would like to thank the community, which is making this possible. And also one specific person from the community who suggested us actually to apply for this conference. So thank you very, very much. And thanks to all of you for your amazing work today. Everything went very, very smooth. And thank you so much. Thank you.
Thank you. Okay.
And now we have Mark Hanley. It may be 3:40 in where he is, right?
Yeah.
3:40
yeah,
in the morning.
it's really.
Okay, here is.
Thanks for staying so long.
Hey, hello guys. Thank you so much. We're all really thrilled. So thank you very much on behalf of myself, Tim and Machine. I just looked at the clock, and this is definitely the latest I've stayed up in about a decade. And it says something about how my life has changed, that it's for a stats package conference instead of something else. But it's been an amazing event tonight. So thank you all for making it run so smoothly. And we look forward to the main event in June.
Yeah, thank you.
Thank you.
Good night.
Thank you for submitting and for staying up late.
Thank you.
Okay, actually, want to say that the full event is available in YouTube. So if you want to rewatch it, it's in the IRAM profile on YouTube. And so you can see specific presentation or the whole event if you want. Okay.
Yeah, and again, I'm really sorry that we can't have Ricardo on stage.
Yeah.
I mean, he was meant to close this event, and he was meant to do the awarding ceremony. So I'm really sorry I had to replace him, because this was really more. I mean, it's an idea that started from him and Francesca.
How during IRAM they will have another time.
Yeah, exactly.
Okay.
Yeah.
There's.
Okay, so
Okay. So,
Maria Clara, if you want to say a few words just to close the event.
Yeah, I just I'm very happy that you all were here, that you stayed up to the end, and I'm really grateful to all the contributors and people that applied. And you can still watch all the contribution in the CovidR Gallery, so feel free to browse them and check them. Now it's a kind of repository of works around coronavirus made with art. So yeah, and I'm really thankful for all the organizers. So to all of you guys that did this great job. And I hope to see you at IRAM from the 17th to the 20th of June. You can follow everything from all our social channels. We have a Twitter account, a Twitter profile, a LinkedIn, a Facebook, and a YouTube. So if you look for IRAM 2020, then you will find everything. And you can keep yourself updated with all our initiatives.
I think you can also stay in this event a little longer.
Yeah.
So if you want to go to the networking area or browse the sponsors.
Yeah. I add another word about the sponsor. Now you are reminding me. So there will be still Mirai Solutions.